All right, let's do some homework. So if we start on, let's see, number 7. So if we start 1.5 with number 7, it says write a formula if this graph has been shifted down 3. So to move down 3, we take all the old outputs and subtract 3. And then it says to the right 1. So then if we go to the right 1, well, we're messing with x, and we do the opposite of what we would think, and we subtract 3. Okay, so that's number 7. Number 9, this is number 7. Number 9 says I've got this function, and it wants to shift it up 2. So if I go up 2, I'm going to take this whole thing and I'm going to add 2, because I take all my old y's and I add 2 to them. That shifts it up 2. And then if I go left 4, I guess I'm going to mess with x. And so left 4 would do the opposite of what I would think, and it adds. Okay? And that would be your final function. So there's 7, 9. Let's look at 13. 13, describe how the function is changed. Y equals f of x minus 4. It does the opposite, and this is right 4. 17 is y is equal to f of x minus 7. This messes with y's. You take all your y's and subtract 7, so this is down 7. 19, if I have y is equal to f of x plus 4 minus 1, remember, order is important, and we work from the inside out. So the first thing that happened is this thing moved to the left 4, and then we took all our old y's and subtracted 1, so it moves down 1. Order matters. Okay, maybe not on this problem, but definitely on future problems. Determine the interval on which these things are increasing, decreasing, or constant. So what I would do for number 21 would be to say g of x is equal to 5x plus 3 squared minus 2. I would say, what is the parent function? So where did you start? I think you started with x squared. And if I work inside out, the first thing is I added 3 to all of the x's. And when you do that, that shifts the whole thing to the left 3. And then I think you multiplied all of your y's by 5. We'll talk more about this next time. It is a vertical stretch by a factor of 5. So it's a vertical stretch. And then we took all those old y's and we subtracted 2. So if you take all of your old y's and subtract 2, then that moves the whole thing down 2. So I start with my parent function x squared. First thing I do is move it to the left 3. So now instead of 0, 0, this is negative 3, 0. So 0, 0 got moved to negative 3, 0. And then when I do a vertical stretch, it's still going to have a 0 there. It's just going to stretch it like so. And then when I move it down 2, I'm now going to have a point at negative 3, negative 2. It's going to look something like this, right? So if you ask me, where's this thing decreasing? It looks like it's decreasing from negative infinity to negative 3. It's decreasing. And then over here, it looks like it's increasing. So it looks like on negative 3 to infinity, it's increasing. And we got all that from thinking about the parent function and how it moved, how it translated. Okay, so that was number 21. So that's 21. And so now if I look at 23, 23 is k of x is equal to negative 3 square root of x minus 1. Again, we work from the outside in. So here's x, the parent function is square root of x. I think the first thing that was done to it was this. So that multiplies it by negative 3. That's going to reflect across the x-axis and at the same time scale. It's going to be a vertical stretch. So the 3 does a vertical stretch and the negative does a reflect across the axis. So if this is square root of x and it has a point at 0, 0 and 1, 1, then we multiply by negative 3. It's now going to have a point at 0, 0 and 1, negative 3. But then if we take that whole thing and shift it down 1, because that's what this thing does, right? We'll make it blue. This negative 1 makes all of your old y's, because this is negative 3 square root of x. It takes all those old y's and subtracts 1. So if I subtract 1, that moves everything down 1. So now instead of 0, 0, I'm down here at 0, negative 1. And instead of being at 1, negative 3, I'm at 1, negative 4. And it looks something like this. So if you ask me where is this increasing, decreasing, or constant, as I walk from left to right, it looks like it's decreasing. Looks like it's decreasing on 0 to infinity. Again, we got that from thinking about the parent function. What is the parent function? The parent function was square root of x. The first thing that was done was a reflect and stretch. And then the next thing that was done was we went down 1. So first we did a reflect and stretch, and then we went down 1. Okay. So that's 23. If I look at 25, 25 says that I've got the graph of y is equal to 2 to the x. So if this is y is equal to 2 to the x, we know it goes through 0, 1. It has a horizontal asymptote at y equals 0. So hopefully you've seen this graph before. It says if that's 2 to the x, then 25 asked me to graph h of x is equal to 2 to the x minus 3. It's just going to be the same picture, except now I have a horizontal asymptote at y is equal to minus 3. The whole thing is moved down 3, and so it should look like this. Now instead of being at 0, 1, this is going to be at 0, negative 2, because it moved down 3. 1, 2, 3 to 0, negative 2, and that's what it should look like. Okay, so that's 25. Let's look at 28. 28 said to graph this thing. So for 28, it says that h of x is equal to absolute x minus 1 plus 4. So again, I would say, what is the parent function? It's this. And if I work from the inside out, away from x, first thing that was done was to replace x with x minus 1. That does the opposite and moves it right 1. And then here we have absolute x minus 1 plus 4. That takes all your old outputs and adds 4. That moves it up 4. So let's do that. So I start off with absolute x, which has the points 0, 0 and 1, 1 on it. So that's absolute x. And then if I move right 1 first, then now I am here. And now I have the point 1, 0, 1, 0, and 2, 1 on my graph, because I added 1 to everything because I moved right. But then I take all my old y's and add 4. So if this is the graph of absolute x minus 1, then if I add 4, it's going to be 1, 1, 2, 3, 4. It's going to be up here. And it's now going to have the point 1, 4 and the point 2, 5 on it. That would be absolute x minus 1 plus 4. Cool. So first I move to the right one and then up 1, 2, 3, 4. All right. Notice how all this work needs to be shown to get full credit because you're working on showing your understanding. Let's look at 29. 29 is k of x is equal to x minus 2 cubed minus 1. First thing I say is what is the parent function? And that parent function is x cubed. First thing that happened was I moved it to the right 2. And then the next thing that happened was I moved it down 1. So I know what x cubed looks like because I have it memorized. So I'm going to go ahead and copy this. Right. I'm going to copy that thing. And the first thing I do is I move it to the right 2. So bloop, bloop. I hit paste. I'm going to move it to the right 2. So it's going to look just like that. So my original, I had 0, 0 and 1, 1. Now I'm going to have the point 2, 0 and 3, 1. So this is x cubed and this is x minus 2 cubed. Well, then I'm going to move the whole thing down 1. So let me do it, well, whatever. Okay, so it's going to look like that. I move the whole thing down 1. Then instead of 2, 0, I'm going to have 2, negative 1. And instead of 3, 1, I'm going to have 3, 0. And so that last one right here is going to be your final function, x minus 2 cubed minus 1. And that would be 29. 32. 32, it wants to know if you have the following table, and I'll take a picture of it. So you have the following table. It wants to relate together F and G and H. So notice if we went from -2, -1 to -3, -1, and then -1, -3 to -2, -3, it looks like every time we are subtracting 1 from, let's think of it this way. We move left 1 to go from F to G. So I think G is this thing moved to the left 1, so it'll be x plus 1. Well then, when we go from f of x to h, well, let's look here. Here I went from 0, 4 to 0, 3. I went from 1, 2 to 1, 1. So it seems like when we go from here to here, we are moving down 1. So I think h of x is going to be all your old outputs minus 1. So we've moved to the left and we've moved down. Okay. So there's 32. Whoop, whoop. So there's 32. What comes next? I guess 34. So 34 has the following picture. Let me take a picture of that. It's just easiest to do it this way. Ooh, remember, 34 is up here. It's always above. I'm not going to make that mistake for the 100th time. So use photo. Let's, let's crop. Boop. Boop, boop. So if this is what 34 looks like, let's see. It looks like y is equal to x squared was our parent function, right? So when you go over 2, you get 1, 2, 3, 4. So yes, this looks like x squared to me. So it looks like x squared, and it looks like it looks like they moved it left 1 and down 3. So left 1 and down 3. Well, if you want to move left 1, I think you would become y of x plus 1 squared. And if you want to move down 3, it would be x plus 1 squared minus 3. So that would be the equation of the function shown in the graph. That's 34. If I look at 36, and taking a picture of 36, if that is your graph, well, let's see what they did to this graph. It's actually a pretty good first picture. So for 36, it looks like my parent function, just like we asked last time, we really said, what is the parent function? And we said it was x squared. Here I say, what is the parent function? And it's absolute x. So that's where I start. Think about where the origin moved. It looks like the origin moved over to and up to. So I think it moved left 2 and up 2. So it moves left 2. It does the opposite of what you would think. So it would be this. And then up 2 is going to take these old outputs and add 2. So this would be the graph of the function shown in the figure. So if that's 36, then I go to 38. 38, kablamo. Use photo. Let's see what 38 has got to tell us. Well, it's the same sort of deal. What is the parent function? So because I have it memorized, I can see that the parent is the square root of x, because I've got 0, 0, 1, 1, and then 1, 2, 3, 4 goes up to 1, 2. So yeah, that looks like the square root of x to me. And it looks like they, if I think about where 0 moved, it moved from here over to here. So I think the only thing you did is move left 3. So the new function would be x plus 3 is the graph shown in the figure. If that's 38, and then you ask me to do 44, I would take a picture of 44 like so. Say, look, here's 44. And then I would crop it like so. So if that's 44, then I say, hey, that looks like my parent function x cubed. And the first thing they did was they reflected it. So it should look like this, but they reflected it across the y-axis. And so they got, at some point, they got negative x cubed to make that flip, yes? But then the origin got moved over 2 and up 1. So it moved right 2 and up 1. So if you move right 2, it would be x minus 2, because it does the opposite of what you think. And if we move up 1, then we would add 1 to all of the old y's. So that would be what your function is, the one shown in the figure. Now, if I was really thinking about it, if order matters, I work from the inside out, and they actually moved, oh, poop, why did I change that to a plus? They actually moved right 2 first, then they reflected it, then they moved up, if we want to be actually proper in the order. So that's 44, and last but not least is 46. I look at it, I take a picture, I say, yay, I'm about to get to have my lunch. And I crop the picture, bloop, bloop, bloop. What does 46 look like? Well, to me, because I have it memorized, that reminds me of the absolute value of x. So last time, again, we said what was our parent function first, and our parent function was y equal to x cubed. And the first thing we did was we reflected. So here, we ask what the parent is, and we say it's absolute x, but it looks like they have reflected it also. That's why it's negative, because it's opening down. So reflect across the x-axis. Other things that have happened is this would be 0, 0. Looks like it's moved over 2 and up 3. So it looks like it's moved. Let me do this. Oh, poop. So we reflect to here, and then I'm going to move it right 2, which would make it do this. Then I'm going to move it up 3, which would make it do this. So now if I look at this function, really we've moved it right 2, then we reflected, and lastly, we shifted it up 3 to get the final picture that you see right there. Cool. All right, that's it. Have a great day.